So today we are going to talk about direct substituting and piecewise functions. Direct substitution is the very first thing you try to do when evaluating limits algebraically. So you don't have a graph, you don't have a table, you just have a function. Your first step is going to be direct substitution. And then you just simplify. If you have a piecewise function that has multiple functions, all right, so for piecewise functions, you have to check the left and the right hand limits. All right, you have to check them both if you have a piecewise. Okay, so we're going to start here on example 39. It says the limit as x approaches 2 of 3. Now, I'm not going to draw the graph after these first couple examples, but just to make the connection, if this is my graph of 3, that would be a horizontal line up here at 3, right? So no matter what x value you're approaching, what is your limit going to be? 3. And if you think about, as x approaches 2, and this is my function here, is there any x in here for me to plug 2 into? No, it's just 3. And that's why your limit is just 3, because no matter where you approach on this line, you get 3. All right, so now my next one. The function is y equals x. So as I approach -4, what is the y value getting close to? -4. And if you had this function here, x, and you were to sub in -4 for the x, you would just be left with -4. Okay, I'm not going to draw the graph for 41. It's a quadratic. We're just going to directly substitute. So x is approaching 2, which means I'm going to plug 2 in place of that x value. Bless you, bless you. And so you're going to get 2 squared, which is going to end up being 4. And so your limit is 4. All right, on 42, I have the limit as x approaches 2 of 4x cubed plus 3. Once again, we're not drawing graphs anymore. Now we're just going to work this out algebraically. So we're going to plug 2 into the x spot. So you're going to get 4, 2 cubed. Ooh, my voice sounded weird, right? 2 cubed plus 3. All right, what is 2 to the third power? 8. What's 4 times 8? 32 plus 3? 35.
Oh, even she laughed at you.
Are you meaning to have these
It's slow because I'm recording, so it's lagging a little. Sorry. Yeah.
It says something wrong.
All right. On 43, we are going to do the same thing as we're going to plug 0 in for x. 2 times 0 minus 1, which is going to be -1.
That's 2 wrong in a row.
You might have e's and you might have some trigs, but then yeah. All right, stay focused. I'm not done yet. On this one, the limit as x approaches 3, so we're going to plug 3 in here, so you get the square root of 3 plus 1, which is going to be 2.
2.
All right, now you may come across some trig. No, unit circle.
What?
Oh, no.
So this is why we need to know the unit circle is because tangent of 0 is going to be asked on a non-calculator part of this test. They are easy questions. They're not questions that you want to just be like, I'm just not learning the unit circle, so I'm just going to miss those. It's a really terrible idea. Okay. So first of all, the ratio for tangent is what over what? Y over x. And so I'm going to draw my unit circle. Dang, it disappeared on me. Okay. As a refresher for the unit circle, you've got a couple options. We've got the corner points, which you should know. You should have those guys memorized. If you don't, you need to get them memorized. This is 0, pi over 2, pi, 3 pi over 2. So if you don't have those corner points memorized, you should get them memorized. And the coordinates at all of those are going to be 1 and 0. So this one would be 1, 0. This one would be 0, 1, negative 1, 0, and 0, negative 1. Because the unit circle is all a radius 1. So if you don't have those memorized, you at least should know the corners. And then from there you have the quarters, which are all going to go by a fourth. So this first one's going to be pi over 4. And so you would go pi over 4, then you would hit your corner, which would be 2 pi over 4. So then that would make this next one 3 pi over 4. And then you'd hit your corner, 4 over 4. And then this one would be 5 pi over 4. Then you'd hit your corner, and then you would have 7 pi over 4. What do I know the coordinate of all of the 4s are going to be? Like what numbers?
Negative 2 over 2.
Yeah. Square the 2s. It's the ones with the 2s. It's the exact same thing. Square root of 2 over 2, square root of 2 over 2. In this quadrant, the x would be negative. In this quadrant, they're both negative. In this quadrant, the y is negative. But if you have one of the 4s, your coordinate point is square root of 2 over 2. Does that make sense? Okay. Then I'm going to erase that just so it doesn't get a little too complicated. No, you can just keep adding to yours if you want. All right, then you're going to have the 6s, which is the more complicated one. Okay, so you are going to start with 1/6. So this would be 2/6, which reduces to what? Pi over 3, 1/3. So 1/6, 2/6, 3/6. This one would be 4/6, which is 2 pi over 3. Then this one would be 5/6. Then you have your corner point, 6/6. This one would be 7/6. This one would be 8/6, which is 4 pi over 3. 9/6 is your corner point, which is 5 pi over 3. And then 11/6. Ooh.
Oh, goodness.
Yeah. 11 pi over 6. So that's where all of your radians are for all of the 6s. So I would just count. Now for your coordinates. On the first one, pi over 6, your options are either 1/2 or square root of 3 over 2. I like to draw the triangle. And so when I draw the triangle right here, which side is longer, the x or the y? The x is longer. So the x is going to get the square root of 3. The y is going to get the 1. Now, if you're talking about this point right here at pi over 3, and you were to draw your triangle, which one's longer? The y is longer. So the y is going to get the square root of 3 over 2. The x is going to get the 1/2. We're not going to fill out the whole circle, but that's kind of a refresher. And so that way, can I erase the circle?
Yeah.
Okay. Just get it out of here. So that way on the AP test, if I come across a question that says sine of 5 pi over 3, I do not have to recreate the entire circle. I can draw my circle. I know that this is the same thing as 10 pi over 6, so I'm going to count my 6's to 10. So I'm going to go 1, 6, 2, 6, 3, 4, 5, 6, 7, 8, 9, 10. This is where my coordinate point is. If I draw the triangle, what's longer?
Y.
The y. So the y is going to get the square root of 3 over 2. The x is going to get the 1/2. And because you're in this quadrant, the y is negative. And then you found your point without having to recreate the whole thing. Does that make sense? Because everything is timed. And so you don't want to, and then I'm not really sure. Someone asked if you recreate it in like section 1. I don't know if you can have that paper throughout all 4 of the sections. So like you're talking about recreating it 4 different times just to have the unit circle for like the couple questions that may be on it. But the thing about the unit circle questions is they're easy questions. So they're easy ones that you just need to know the circle. So they're not ones that you want to just miss. Okay. So back to my original question. I've got tangent of 0. The ratio is y over x. So on my unit circle, always does that to me. 0 is right. I'm doing it. Okay, 0 is right here. The coordinate is 1, 0. And so the y value is going to be 0. The x value is going to be 1. And 0 divided by 1 is 0. And so then this limit would be 0. Okay, I've got another trig one. So we're plugging in pi in. So in place of the first x, I'm going to put pi. And then cosine of pi. So where's pi on my unit circle?
It's at the
-1, 0.
Yes, right there, -1, 0. Is cosine x or y?
cosine is x.
Cosine is x. And someone asked if there is a way that you can remember that. Besides it being alphabetical, like C comes before S and X comes before Y. I haven't really come up with anything clever, but I'll think on it. All right, so the X value is -1, so this answer would be -pi. Okay, and then my last one. The limit as x approaches 0 of sine squared x. So the notation, the way sine squared is written, you kind of have to get used to this being the same thing as sine of 0 squared. For whatever reason, if they're squaring the letters, it means you're just squaring that whole trig value. So if I were you, I would rewrite it so it looks more normal. So we want to evaluate sine of 0. All right, 0 is right here. What's the y value at that point? 0. Because it'd be 1, 0, right? And sine is the, okay. And 0 squared is? 0. Okay, so direct substituting, are we good? All right, now we got piecewise. All right, so it says, given the function below, find the following limits. So I have the square root of 11 minus x for x is less than -5. And I have x plus 3 over 5 minus x squared for x is greater than or equal to -5. The first question asked me, what is the limit as x approaches -5 on the left side? So we have to decide which one of these functions is going to be on the left side of -5. Which one? The first one. How do we know that the first one is the left function? Yes, because it's less than. So when I direct substitute -5, I'm only direct substituting into the top function, not the bottom one. So that's going to be 11 minus -5. What happens with a double negative? Turns positive. So you get 16, which is going to be 4. All right, so on letter B, it says the limit as x approaches negative 5 to the right side of f of x. Which one of these functions would I use for the right side? The bottom.
Probably what did you say?
Because it's greater than. And what are you going to plug in for x? Negative 5. So negative 5 plus 3 over 5 minus negative 5 squared. All right. What is negative 5 plus 3? Negative 2. What is negative 5 squared? 25. Order of operations says you have to square first, so that's why I squared that to be a 25.
20.
And then that's going to be negative 20.
So 10. Oh, wait.
1/10. 1/10. So yes, your right side limit is going to be 1 over 10. All right, now for part C, it says the limit as x approaches negative 5 of f of x.
Use the bottom one because the whole thing on.
No. What has to be true for your limit to exist?
They both have to match and coming from the
Yes, they both have to match. So for my limit to exist, this is the definition of a limit, the left-hand limit has to equal the right-hand limit. Does the left-hand limit equal the right-hand limit?
No.
No, so what is the answer to C? Does not exist.
Oh, that's easier.
Yes,
Wait, no, actually, wait, I'm confused. The left hand of what?
the left-hand limit. So on the left side of my function, that's this one.
Yeah.
I got
that
4.
one and that one.
And then the right side of my function, I got 1 over
I don't know
10.
what's so funny about that. I was trying to ask a question.
And so they don't exist. Okay, now, it's not in the notes, but I probably should have put it in. Shh. For a point, let's say I asked about f of negative 5. What function do I use for f of negative 5? The specific point. Why the bottom one?
Because the one.
Yes, because of the line. So the line does matter. It matters for the points. So this one, you would use the bottom function.
I think that's what I was thinking of.
Yeah. Because of this line, the or equal to line. So if you're, and it's going to ask you on your homework about a point. So if you're asking about a point, you need to look for that or equal to line. That's going to tell you what function to use. For if it doesn't specify left and right, you have to do both. All right, so down here on the bottom, I've got a piecewise, and this piecewise has 3 functions. Which is okay, it's just split up in 2 different points. So if you look at your domain, it's split up at -1, and it's split up at e. That's just why I have more functions. So on the first limit, the limit as x approaches -1 of f of x, I need to check the left-hand side of -1, the right-hand side of -1, and see if they're the same thing. So even if it doesn't specify, you still got to check. So for the limit as x approaches -1 from the left side, which of those functions am I going to use? The first one, because that's when x is less than -1. So the square root of 10 minus -1 squared. What's -1 squared? 1. 10 minus 1? Square root of 9? 3. All right, so I did the left side. The left side is 3. Now I have to do the right side. So now I'm going to take the limit as x approaches -1 to the right side of f of x. And which one of the functions am I going to use for the right side of -1? The middle one. All right, not the blue one, because that is dealing with e, not -1. So the middle one here, 26 minus 5 times -1 squared over 7. All right, what is -1 squared? 1 times 5 is still 5. And then 26 minus 5 is 21. And 21 divided by 7, 3.
So they match.
So they match. So since the left-hand limit and the right-hand limit are the same thing, what can I say about the limit as x approaches -1 of f of x? It exists, and it's what? 3. What about f of negative 1?
Negative 1. Oh, wait.
The middle. Wouldn't it have to be the middle one because the other one doesn't have one?
Do either of them have lines?
Yeah, it's not.
Nope. So neither of the points at 1 have lines, so they're both holes, so the point doesn't exist. The limit exists, the point does not. All right, so let's try E. All right, so I got to do the same thing. I got to do left and right side, so let's do the left side first. All right, the limit as x approaches E from the left side. Which one would I use for E on the left? Say it again.
The middle.
The middle one, yep. So 26 minus 5E squared over 7. All right, do you know what E squared is?
It's a natural.
It's not a log. You are on the right track. But E is just, it's like pi. 2.718 squared, which, geez, we don't know what that is. So this is as far as you can go. Yeah. You can't really do anything with the E squared, and we can't reduce anything. So that's as far as we can simplify that one if we didn't have a calculator. Otherwise, it would just be a nasty decimal. All right, so then we're going to do the right side. So the limit as x approaches E from the right side of f of x. Which function would I use for the right side? The bottom one. So ln of E cubed. Now let's say you don't know, you forgot your log rules. All right, even if you forgot your log rules, are those guys the same?
They cancel. No.
No, they're not the same. So is your limit going to exist?
No.
No, your limit's not going to exist. What were you telling me, Jeannie?
I was
You were right.
remembering You cancel them out because it's.
Yes, the ln and the E will cancel, and you're going to just be left with 3. So that you can simplify ln of E will cancel out, and you're just left with that exponent 3 there. But still, they are not the same thing. Now, what if I wanted to know what f of E was? Which function would you use?
Use the middle.
The middle one. So you would get that 26 minus 5E squared over 7.
JK.
Okay, does that make sense? Okay, you're going to have a homework quiz over this tomorrow. For the rest of class, you are going to start working on your homework.